as a wave. These two are moving on a string. Okay, no, so they will, after some time, what will happen? They will arrive at this position. So I'm interested in this particular point P on a rope. When the waves arrive there, when the waves arrive there, so there will be like a, what is y1? Y1 is a traveling wave. Okay, what do you mean by traveling wave? Traveling wave, where the energy propagates, that's why we call that as a traveling wave. Is it okay? The energy propagates, that's why we call that as traveling waves. This one. Both these are real waves. Huh? This is a real, this is a real. Earlier we took one imaginary, one real. Now let me both the real erect waves or say erect pulses or erect waves, they are moving. I'm interested at point P. So what is the displacement of point P at a certain instant of time? Both the waves arrive. Let me give some other. Yeah, both the waves will arrive. So let the amplitude A1 and A2. What is the displacement of point P? Yp is equal to given by y1 plus y2. This is at t equals 0. Let's assume after some time t, both the waves will arrive here. This is a rough diagram. Huh? This is a rough diagram. Now, what is the total displacement of point P? Will be individually due to each wave. If only wave 1 is present, the displacement will be maximum displacement will be A1. When only wave 2 is present, maximum displacement is A2. When both are present, A1 plus A2. Okay, this one. So now it will be A1 sine omega t minus kx. Let's assume that at certain time, or we'll say that this is t less than 0. At t equal to 0, they are undergone superposition. So put t equal to 0. So this will become, I will write this one because we are, again, you'll encounter negative sign. Okay, no. Now you put t equal to 0. So this will become A1 sine kx. What is x? I'm defining this is x equals 0 at a certain position. So define the position of that particular thing. So further, how do we write? This is 2 pi by lambda. Okay, the displacement of that point is given by this particular thing. At different instants of time, when the waves arrive there, at an instant of time, you can find out what is the displacement of point P. So what is the displacement of point P? As if only wave 1 is present, then what is the displacement is given by A1 sine 2 pi x by lambda. If only wave 2 is present, the displacement of point P is given by A2 sine 2 pi x by lambda. When both are present, you take the algebraic sum, because sign can be positive, negative also. So it is like a algebraic sum is what we are going to take, not just only additive. Algebraic sum, I say that, because sign can be positive or negative. This is called like a superposition principle. I think long back you have come across where superposition of SHM, there you have come across. Then again in the laws of motion, when a body is acted upon by two forces, then how to calculate the resultant acceleration. Superposition principle, F1 plus F2 by M. First calculate only acceleration due to force F1, only due to force F2, then take the vector sum A1, A bar equal to A1 bar plus it. The same idea is what we are implementing for waves also. Sir, what happens if there is a rope, there's a rope, and we have the waves like this, V1, this V2, this having a some phase. Let's assume that one. So what are the equations? I'll write it. Y equal to Y1 plus Y2. A sine amplitude, let it be A1 and A2. So A2 sine, this one at t equals 0, let they undergo superposition, displacement of point P. Look at no. Even if one of the wave is having some phase, okay, no problem. Bring that phase into picture. This you have come across somewhere. Can you recollect? Superposition of SHM. How to find out the resultant amplitude at that instant of time. I think we are in a better position. So what is the resultant amplitude? So the wave will be, say, some other phase angle. Let it be alpha. Then what is AR? AR is given by, okay, I agree this one, and you can calculate the phase angle also by vector addition. So like this, we can even go for superposition of three waves. Not only this, three waves also. If three waves are moving, if they undergo superposition, y equal to y1 plus y2 plus y3. We'll take a general discussion. Here I defined x equal to 0, this point as x equal to 0. You can pick up, at a distance x I picked up t equals 0. At any instant of time, if they give, so that substitute that particular time. So here for our understanding purpose, I assume t equals 0. No, sir, at t equals 2 seconds, if they undergo superposition, put t equals 2 seconds here and solve it. Getting it need not be always at t equals 0. Just to make understand, theoretically I brought it here. Even at any instant of time, sir, at t equals 2 seconds. So you know omega, you know time, substitute that. Then again, somewhere we'll end up equation of like this only, and solve it. Okay, no? This one. So even three waves, we can extend this concept. Not only this, it should be even for three waves also. Three waves are there. So amplitude A1, A2, A3. So superposition of some point should be equal to y1 plus y2 plus y3. Individual phase of the each wave. Actually, V1 equal to V2 equal to V3 because both the waves are on same string, no? Okay, see, no? Not only at t equals 0, let at any time, at a given position, at any time, okay, put that particular time and we can solve it. That there's no problem for this. Superposition of 3 more than, if n waves undergo superposition, we can do it. So this is moving towards left, put positive sign. Sir, both the waves can undergo superposition when they're moving. Can be because of some phase difference, can be. Okay, got the idea. So if you look at the advanced paper, we do have a question on superposition of transverses on a rope where he has asked a question of like this. You have to be careful. Just it's a simple SHM idea only. Alpha is the phase of the resultant wave. Okay, the simple idea which will take. So now what we have, both are real pulses. When both the real pulses undergo superposition, what we do, we use a method of like this. Shall I scroll down? Huh? We'll take the next one. If both are real pulses, both are real identical pulses.